So in this video, we're going to review exponential functions and their graphs. So an exponential function is just a function of the form a to the x. A can be any number as long as a is not 1, and a also has to be greater than 0. Those are the two things with exponential functions. So just to kind of remind ourselves of how this works, so let's say I have the functions f of x equals 3x and g of x equals 1/2 x. Okay, so how do we evaluate these? Well, we know with functions, if I ask you to find f of -2, so I'm referring to this function, and I'm going to plug in -2 for the x. And so just the tricky thing that sometimes, stops people or whatever when they're working with this is, what do I do with the negative exponent? So you rewrite this where you flip the numbers. So a negative exponent is always really referring to taking the reciprocal of whatever it's attached to. And then you can evaluate this. So this is just 1/9. So the value of f of -2 in this case would be 1/9. Okay, so what about f of 3/2? Well, now I'm going to plug in 3/2 into this. Now, the thing about this is that this is a rational exponent. So what this is trying to say is to take the square root of 3 and then to cube it. But we know that we cannot evaluate the square root of 3 without a calculator. So if you can easily evaluate the root, then, just go ahead and do it by hand. But if you cannot do this without a calculator, then just use a calculator. And you can plug 3 to the 3/2 into a calculator. Just make sure that when you do it, so you use the little exponent sign, and then make sure you have parentheses around. So let's see, parentheses, 1 parenthesis, 3 divided by 2, and then another parenthesis. So just make sure that when you plug this into a calculator, you put parentheses around that entire rational exponent. So when I plugged this into my calculator, I got a decimal, so we'll just round this to 5.196. So that's what that comes out to. Okay, so let's now pivot to g of x. Okay, so I recommend trying these on your own just to make sure that you've got it, and then hit play when you think you're ready. Okay, so if I plug in -3 into my g of x function, so once again, so this is a negative exponent. So what this means now, since this applies to an entire fraction, is I just flip the fraction to get rid of the negative exponent. And this really, then this is 2/1, so that's just equal to 2, and 2 cubed is equal to 8. Now, if I plug in g of 3.2, so if I plug in that 3.2 exponent, this I cannot do without a calculator. So this just equals 0.1088. There you go. Okay, so let's review, now that we've kind of remembered some of the things about just evaluating these types of functions. So let's pivot to what the graphs look like. So what I have here is I've got a graph and I've got a table set up. And I just have a bunch of different points for the table just to help us figure out the shape. So if I plug in -2 into the function 2 to the x, so we know that 2 to the -2nd, so I've got all the work here, 2 to the -2nd is equivalent to 1/2 squared, so this just equals 1/4. And then if I do 2 to the -1st, so that's just going to be the fractional form, right? So 2 to the -1st will just be equal to 1/2. Now the thing that a lot of people forget, what is 2 to the 0? It's 1, 1, and then if I plug in the positive exponents, 2 to the 1st is 2, and 2 squared is 4. Okay. So now I want to just take all of these points and I just want to plot them on my graph. So I've plotted all my points, as you can see here. And okay, so the only other thing I really want to think about before I draw this graph is, will the graph ever cross the x-axis? Meaning, can my y values ever be negative? And the answer to that is no. So you can plug in any negative number that you want into this, and it will never make this function go negative. What the negative numbers do in this example is that they are negative exponents. So they will just turn this into like a tiny little fraction, but the fraction will never go negative. So the way that the graph looks is it's like this. It stays above the x-axis. It'll get really close to the x-axis, but it will never cross the x-axis. So this is one potential shape of an exponential function. So an exponential function has this sort of shape, so it increases as x increases, when the value here this a is greater than 1. So we'll see the other shape it can take in a moment. Now the x-axis is an asymptote for this graph. And then the 3 points that you're generally looking for with a graph like this is really like these 3 points here, but these 3 points are dependent on what your a is. So the 3 points you can always count on are every graph will always have 0, 1, the basic graph, 1a, and -1 and 1 over a, so -1 in the fractional form. So these are like your 3 standard points, and then you can translate from there. And okay, and then the domain of this graph is all real numbers from -infinity to infinity, and the range goes from 0 to infinity. Okay, so now let's pivot to the other way that these types of graphs can look. So what if I have 1/2 to the x? Well, I'm going to do the same thing with the table. So I've got the same x values that I'm going to plug in here. So if I plug in -2, so just to show you the work. So if I plug in -2, remember the fraction will flip. So this just becomes really 2 squared. So this will just equal 4. So I've got the work up there if you want to review it. So then if I were to plug in -1, this will just equal 2. Anything to the 0 power is still equal to 1. And then if I plug in 1/2 to the 1, that equals 1, and 1/2 squared, so then you just square the top and the bottom to get 1/4. Okay, so once again, so we're going to do the same thing. We're going to plot the points. So I've got my points plotted here. And it's the same argument as we had with the last graph. So this graph will still never go off into these negative y values because this will always stay positive or just above 0. So the graph will look like this. So this is like the other type of shape that an exponential can take. So the graph of a to the x takes this type of shape when a is a number between 0 and 1. So this is 1/2. So as long as you're just a fractional base, this will be the type of shape that your graph takes. Obviously, it will change a little depending on what your a is, but it will at least open up in this direction. Now, the x-axis is still an asymptote in this case. And then the 3 points that we can count on, we still have -1, -1 over a, 0, 1, and 1a. Those are still the 3 standard points. So you always want to just calculate those 3 at a minimum just to get the basic shape of the graph. And the domain is the same as it was in the other graph. So that's kind of the basics with exponential functions. And translations work like always. I've talked a lot about in this series about how translations work. So all of that still works the same. So the only thing is I know that graphing with translations can be a little confusing. So I just kind of want to walk you through how to think through that if you're, nervous about it or whatever. So, okay. In this case, I've got -3 to the x plus 1. So the negative here, so if we just kind of unpack what's happening, so the graph we know will flip over the x-axis, and then the plus 1 means the graph moves up 1. Now, we might feel a little disoriented though about like how that actually translates. So if that happens, you can always make a table just to get like 3 basic points. And you kind of know the 3 points that you're looking for now. So if I plug in -1, 0, and 1, this graph did not shift to the left or to the right. So I can still plug in these 3 points, right? And I'll just kind of get a sense of how everything works together. So if I plug in -1, so let's see, if I plug in -3 to the -1 plus 1, so you just want to be careful how you're thinking about this. So this becomes -1 over 3 plus 1. So what does this equal? This equals 2/3. And then if I plug in 0, so let's see, let me clear some space. So I'll have -3 to the 0 plus 1. So this can kind of mess with your mind a little bit. So this -3 is not in parentheses. So technically what is happening here from the order of operations, a lot of people forget this. When you don't have parentheses around the number, the -1, we really view it as a separate operation. And if you think about the order of operations, PEMDAS, it's exponents before multiplication. So 3 to the 0 is equal to 1, but then I have to do the multiplication afterwards. So this becomes -1 plus 1. So this actually does equal 0, okay? All right, and then just to clear a little more space, so then I have -3 to the first plus 1, so that's just -3 plus 1, which is going to equal -2. So if you're like really kind of not sure of how things, like I know with translations we talk about, oh, it's so easy because the points just move this way or that way, but sometimes these numbers can kind of mess with your head. So you know kind of what should happen to the graph, and you probably have a general sense of like how to get that started. But if you're a little unsure or a little uneasy, you can still plot a couple of points and then just make sure that those points kind of align with a shape that matches our intuition. And this right here is our intuition. Okay, so let me clear some space and make a graph. Okay, so I've got my space now, and so then I can mark my points. So -1, 2/3, 0, 0, and then 1, -2. Okay, so I know that the normal graph, so just to like, you know, kind of wrap our head around this. So the normal graph of 3 to the x would have looked something like this, right? But what I needed to do is I needed to move this graph up 1, and then I also needed to flip it now. So I needed to flip it over the asymptote. So the asymptote that was here, it moved up to y equals 1. So there's just like a lot to think about with this. And if I were to flip this graph over that asymptote, now do you see how this would work? It would be these 3 points. Oops, let me try that again. These 3 points that I sketched out here. So if I take a second to think about it, it does make sense, but I think it's easy to get disoriented with sometimes with the translations. So taking a second to think about, okay, what does the normal graph look like? And then what does that flip look like? That can really help you wrap your head around this, and then it can make the graphing easier. So it's okay if you're a little sketched out at first, but you know, maybe just leaning into it a little bit and thinking about how it all works, it might make it eventually faster for you to graph again. Okay, so let's talk about this other graph now. So I've got f of x equals 1/2 to the x plus 1 minus 2. Okay, so just thinking about what's going to happen here. So this moves to the left, to the left 1 and down 2, right? Okay, so once again, so if you're like a little unsure about those points, you can come up with 3 points. But okay, so here's the only thing. If the graph is being translated to the left or to the right, so you just want to be cognitive then of like how that impacts the 3 points that we were going to choose. So instead of having, so maybe just to bring back the graph for a moment. So a moment ago we were talking about this graph, right? 1/2. So if I wanted to move it to the left 1, so think about how that impacts these 3 points that give me the real shape. Those 3 points, if I move them to the left 1, instead of being -1, 1 over a, that point would now be here at -2. So it would be -2, -1, and 0. That's how those 3 points get moved to the left. So those would be the 3 points that I would want to figure out. So I'm going to just kind of walk you through this. So let me write those points down and the y coordinate. So I've got my 3 points, and I'll just clear a little space here so I can calculate. Okay, so as I go through this now, so I have 1/2 to the -2 plus 1 plus 2. So I can go through and actually do this if I'm uncomfortable. So this becomes -1/2 to the -1 plus 2. So that's just going to be 2 plus 2. So that's going to equal 4, right? Okay, so I recommend that you just try this with the other 2 points before you watch me do them. I'm going to clear some space. So just for the sake of time of keeping this video short, so if I plug in the other 2 points, I've got all the work here just for what those 2 points are. This is me plugging -1 in and 0 in, so if you just want to double check the work, you can pause the video here. So let's go ahead and set up the graph. Okay, so plotting my points, so let's see, I had -2 and 4, I had -1 and -1, and then I had 0 and -1.5. So that would be somewhere around here. Okay, so just thinking about now, like with these translations. So the -2 means that where I had the x asymptote, so the asymptotes move with the translations. So this is my new asymptote. And so then when I just connect my points, so I can see how this totally got moved over, right? So where I had this 0, 1 point, it moved down 1, 2, and over 1, and then the other points moved with it as well. I had enough points to kind of sketch out what this looks like. So again, just taking an extra second just to think about like the translations and how they match up, you can eventually find some confidence so that you don't always have to make the table. But I do say sometimes like the table can be worth it if you're working with a newer graph and it feels a little bit more awkward to you. So hopefully that advice just kind of helps you decide when you want to draw a table versus when you feel comfortable just coming up with the graph on your own. We've talked a lot about translations in this series. Okay, so that's it for this one. Just a quick review of how exponential functions work. So I've got more videos on this. I will catch you guys in another video. Thanks for watching.